For this laboratory, we are required to create a, a virtual private cloud in Amazon Web Service with topology like this. So that so this VPC will have four subnets, one, two, three, four, and three instances: client, server, and VYOS as router. Each instance each instance has has two network interfaces. The first one are used to communicate with each other, and the second interface are used to be able for the instance to be connected through SSH by elastic public IP associated with them. So once we have done this, we will need to do some measurement that actually run iPerf on client and server. So traffic will go from client through the subnet network 1 to VYOS, so to the first interface of VYOS, and the VYOS will forward this traffic to its second interface, which is Ethernet 1, and then it will forward the traffic to the first interface of the server, and vice versa. The first thing we need to do is to create a new VPC. In order to do that, we need to come to the VPC dashboard of the Amazon Cloud Service, Amazon Web Service website, which is here. So to create a new one, hit this button and come to this tab and select VPC only. Give it a name, and the rest are just default. And in here we will give this value 16. Okay, and create this VPC. After hit this button, then the VPC will be created like this. So this is how we create the VPC. So after we created this VPC, we will create the four subnets. Go to this subnet here and hit the create subnet. In here, we need to mention the correct VPC here, because we are in this network, in this cloud. And here we give the subnet the name of the subnet and the availability zone. I will use the 2A for this one, and also mention its IPv4. So the IPv4 CIDR block for the first subnet is 10.0.1.0/24. Okay, /24. Then we hit the create subnet button, and the subnet will be created. So we will repeat the same procedure for all other subnets. Then this is what we will got: subnet 1, subnet 2, subnet 3, subnet 4. Okay, so after we created the four subnets, we need to create a gateway so that the instances in the subnet, in the VPC, can access internet. So in order to do that, we go to internet gateways in here and create internet gateway. Yeah, just give it a name, then okay, all will be done. So after we create the internet gateway, we need to attach this gateway to our VPC. So just select this gateway and choose here attach to VPC, and select the VPC that we created. Then hit the attach button. After that, we will successfully attach the internet gateway to our VPC. Then the next thing is that we need to configure the default route. So we want any traffic that its destination is not the local instances actually go through the internet gateways that we created. So to do that, we go to the route tables in here and select our VPC and go to the routes here, edit routes, and add a new entry. So the new entry will have destination all zero, which means any destination other than this. And so with target, so this will be our internet gateway. Then we save this change. The next thing we need to do is to create 3 elastic IPs. So we want to SSH into all the instances that we will be create them. To do that, go to the elastic IPs here and click this allocate elastic IP address. In here, we select the right region and just hit allocate. And just repeat this same step to create a total of 3 elastic IP address like this. And to be convenient for me, just give them some name. So actually, the preparation work has been done. So there are 2 questions here. So the first question is, how is Amazon be able to convert your public IP and reach your private IP on the internet? So for this question, it is like something like what we are doing here. So I do think there is a net server, network address translation server in Amazon that actually map the each public IP address to the private IP address on the interface. So whatever traffic go through the elastic public IP like this IP address, it will forward to this particular interface, and whatever go to the internet, it will forward the traffic come from the internet, come from the network interface to the internet. Another question is about how could we set how is the permission granted for different users and how to create a new one from. This is done in Amazon by IAM, which is the in identity and access management. So in here, the permission for administering IAM is like, so we need to go to the access management. Permission required. Yeah, in here. So actually, in here we can give some access to some resources, or give access to other Amazon accounts. So this is done by the identity and access management of AWS. After we have created the VPC, we should create new instances. To do that, go to the Instances tab of the Amazon Web Service, the website, which is here. Select the Instances tab and click here, launch the instances. Give it the right name and select the right operating system. Here we search for VYOS, and only one result will come up. The first time we use this mirror, we need to subscribe it. Continue to subscribe. Then in here, we need to subscribe it. After subscription, we can select this to use it to create our instance. Then in the instance type, select the right configuration. For me, I just need to use P3 small. Then we need to create a key pair for logging through SSH. To do that, just click that and give it a name, then create key pair. After this, a file will be downloaded, and we just move that file, which is lab2 PEM, move that file to the home directory of the local machine. Then we will be able to SSH into the instance through this key file. I will show this later. Then we need to configure the network settings. Click Edit here, and we need to select the right VPC. Also select the right subnet. In here, the VYOS is connected to network 1 and network 2, and its Ethernet 0 interface is connected to network 1. So we select the network 1 here. Then we need to configure the security group. The first time we configure this, we need to create a new security group. So in here we will allow SSH, we will allow all TCP, all UDP, and all ICMP IPv4. But since I have created the security group before, then we can select the existing security group and select the security group that we created before. Then click this advanced network configuration because we need two interfaces here. So we add network interface and connect this interface to network 2 subnet and select the network 2. Then we need to give it the correct storage. In this case, 4 GB would be enough. And then launch the instance. So this is the step for creating the VYOS. For creating the client and server, it's basically the same. The name, but in here we select Ubuntu and select 1804. And we can use the free tier configuration T2 micro and select the key, select existing security group. We need to add it and select the right VPC here and select. So suppose this is for the client, so it will be connected to network 1. Select network 1 and select the right security group. Also add another network interface which is connected to network 3. And give it the storage. So here we need to I need to give it a 10 GB because the minimum requirement of the Ubuntu 1804 is 8.5 GB. Then the configuration is done. Just launch the instance. And we will follow these steps to create all 3 instances. The next thing we need to do is to associate elastic IP to the instances. To do that, go to the elastic IP in here, elastic IPs, and select one associate elastic IP address. Here we need to select network interface, and in here select the right interface. So take VYOS as example. Go to the instance and select VYOS and go to the networking tab here and select the right network interface ID. In here we want to connect to the first one, so it will end with 69. So we come to here and select, this one is ended with 69, and also select the right IP address. Allow this elastic IP address to be a 3 associate and select associate. Then this will be done. Then we follow the same steps for the 3 instances. All IPs will need to be attached to the first interfaces of these instances. After that, we need to disable the source and destination checks for all 2 interfaces. To do that, we go to here, instances, and VYOS Lab2. And in here, we need to just click the interface ID. Select this. In action, we select change this and make it uncheck this enable here and click save. Then we need to do this for the second interface of WiiWiOS. Just follow the same step. So why we need to do this? This is because performing source destination checks means that the interface must be the source or destination of any traffic it sends or receives. So we want the WiiWiOS to be a net instance, which means it should be able to send and receive traffic when the source and destination it is not itself. That's why we need to do this. So after that, we can SSH into the client server and the WiiWiOS. How to do that? So we do that by using this command. So this command, which is SSHI -I, and we need to mention the key here, which is the key that we downloaded from the website, and also mention the right username and the public IP address. Then we just run this command, and we will be able to SSH into these instances to disconnect with the instance. Just use exit. Okay. So here we want to use the second interface as the interface that attached to elastic public IPs. So we want to use the second interface to SSH into the machine, and use the first interface to communicate with each other. So to do that, we can't just associate the public IP to the second interface of the client and server, because the second interface of the client and server in default is not enabled. So if this is the first time that we logged into the client and the server, if we run this command ipconfigure, then only Ethernet 0 will be here. Ethernet 1 is not here. But we need to check that if Ethernet 1 is available. So we use ifconfigure if configure -a. So this will show us the Ethernet 1 here, but it doesn't have the IP address. So to do that, we need to modify one file, which is this file, etc net plan sudo vi. So we need to modify this file. So by default, it doesn't have these two lines. So we need to add these two lines, which basically tells the network operating system to enable Ethernet 1 and set this DHCP for internet for IP4 to true. So after this, we also need to run this command sudo net plan apply. So after running this command, the operating system will apply the configuration that we configured in this net plan file. Then the Ethernet 1 will be available, will be enabled, and it will have its right IP address. We still need 3 commands so that we could be able to SSH into the instance through the second interface. The 3 command is this. So basically it is saying that we are using the default routing table to route packages come from the client and server itself, and also then let the default routing table route via this IP address, which is the gateway, through the device Ethernet 1. So this is saying that the package will now go to 10.0.3.1. Then we give this file the right permission, which is the permission to run the char mode 777 and this file name. Then we run this file, and after that we will be able to SSH through the second interface. Now we want the traffic between the client and the server actually using VYOS as their router. So to do that, there are two ways to do that. The first way is to run this command route at, and for host we will mention the host for the server, which is the IP address of server.1.186, and telling the operating system that to reach this IP address you need to forward this package to the gateway. So the gateway, which is the IP, which is the interface that the IP address of the interface that is connected to the same network of this client. So we need to check that address, so which is Ethernet 1, which has the IP address of this 10.0.2. this. So after we run this command, it will add this route information to the routing table. So this is the first way to do that. The second way is actually we can add the whole NAT to the routing table, which is 10.0.1.0/24. And so any package that has destination to this network will use the second interface of the VYOS as its gateway. So after we run this command, a routing message will be added to the routing table. So if we run this route client and server, we can notice that there's on the client here, in order to reach network 2, it will forward the package to Viva OS, the first interface of the Viva OS. So on the server here, if it wants to reach network 1, it will need to forward the package to the second interface of the Viva OS. And to prove that this is actually working, so we will use the TCP dump to listen to the ICMP package. So to do that, we will run this command on the server and the Viva OS router. So, and in the client, we ping the server. Okay, in here we can see that the router is actually, it received the package come from the server, come from the client, which is here, and come to and go to the server. And it will, so this is the first, this is the ping package, and in the server, it received a package that come from the client and actually go to the server itself. Then it send a package back, so that its source address is the server itself and destination address is the client. So this package will go through the Viva OS, which is this package, and it is gonna to forward this package to the client. Okay, so actually it is working. So there's a question: can you answer why SSH goes down if IP is changed on that interface? So that is because SSH is running over TCP. So if we change the IP, then the connection will be interrupted. So that's the reason SSH will go down. Another thing that we need to take care is what I said here. SSH has a name, has a file named known hosts. So for every connection, it has some kind of hash map. Yeah, actually, it is not a hash map. It's just a entry about the internet and also the encryption key. So if we associate this IP address, this same IP address, to another instance, we will not be able to connect to that instance when the old entry of the known host is here. So to solve this problem, we need to delete the old entry here. Then all will be solved. Okay, so this is for this question. Another question is, what can be used in Viva OS virtual machine to start DC client? So we can find the command here by using this command. Okay, so actually, like I mentioned here, in VivaOS it is using this command, this DC client command to start the DC client service. But actually, the DC client service is part of the network manager service. So to do that, we can use this command to restart the network manager service. This will also start DC client in VivaOS virtual machine. The next thing is to check this file. Actually, in my system, this file is not in this path. It is actually moved to this path, net plan. Okay, so this is the file, and this is also the file that I mentioned before. That I added new entry here. Okay, so this is the file, and the next thing is that the VMs are not be able to connect to the internet. Why is this? So the reason is that this client and servers that they don't have the correct DNS server. Actually, they don't have any DNS server. So to check this, we can use this command to check the DNS server. So actually now it is, I have fixed this problem. So it has the DNS. So for both Ethernet 1 and Ethernet 0, it has DNS server 10.0.0.2. And if we run this command when we are not be able to connect to the internet, so these information will not show up. So this is so to solve this, the first one solution is just reboot. Then the AWS will give us to assign the right DNS server to us. The second is to create and modify this file. So in this file, I have added the address of the DNS server, which is the same of the DNS server that AWS assigned to us. Also, the first is the DNS server of VivaOS. So this will solve the problem. When the virtual machines can access the internet, we can install the iPerf and iPerf3 on the client and server. To do that, we need to first run sudo apt-get update. So this will update the package list for upgrade of the package that needs upgrading, as well as new packages that have just come to the repository. So basically, it is just updating the repository so that we could find the right software. After performing the first command, we perform the second command, which will install the iPerf and iPerf3, which is relatively straightforward. Now we will do some network measurement through the iPerf over UDP and TCP. We will also set some parameters to modify the environment of our connection network connection to observe if the different parameters make any difference. So to do that, we will use in the server side we will use this command to start a server of iperf3, which we'll use to measure the bandwidth of UDP. And in the client side, we will use iperf3 UDP and the address of the server. Then it will have the maximum bandwidth, which is 10 gigabits. Yeah. So if we perform this, okay, we have some. Yeah. If we perform this command, we will show the measurement of this measure. So to perform something of TCP, we will use the command start with iperf, and for the server side, it's this. Okay. One thing I need to mention here is that you can see 99% of the datagrams are lost. That is because of the some parameters I set. I will mention that later. Yeah. Okay. So we can see here iperf and the iperf and the bandwidth here. Okay. So next, I will answer these questions later. Okay. So then we will need to change some parameters. How to change the parameters? Just this command. So we will set. If this is the first time, we just. Oh yeah, before doing that, I need to delete the old settings, which is this command. So there ETH0 root. Okay, by doing this command, we will delete the old parameters. Now we will set the new command here. Add 0 root net delay 100 milliseconds. So this is saying that we will tell the network operating system that to add delay on the package that come to this side. So just hit enter. Yeah, this would work, and we'll do this for the same for the server side, and perform those measurements. So then is to set a new parameters which has 0 millisecond of delay but 10% of loss. Yeah, then also perform the measurement. And also the MTU. So to change the MTU is to use this command. So the current MTU is this 9001. And to perform this command, I've configured EH0 MTU. Maybe I change this to 100. Okay. And next, then as you can see here, it changed to 100. Okay. So this measurement is to change the MTU and also do the measurement to the same measurement. Then we will execute this command, which is actually yes, just another modification of the parameters, and also do the measurement. Okay, another thing is here to run this. Running this command will get us a log of the kernel, and I will also mention this later. Okay, then it's like we need also to perform the measurement on the interface that is not attached to the public IP address. Which interface? So it is this interface. So for VyOS, we have two interfaces: Ethernet 0 and Ethernet 1. So but Ethernet 1 is connected to the public IP address. So we will perform we will set some limitations of the set some measurement on the interface, which is this interface, and also perform the whole all the measurements. So how to set that is just run this command in the VyOS and also perform the following measurement, which is here, which is this measurement, and also reach a conclusion. So the first measurement is test the connection over UDP without any parameter set. So in here, we tested the bandwidth of UDP, which has around 1.04 gigabits per second. And also we will test the connection over TCP using iPerf. So we have the max TCP throughput around has this value. Then there's a question why, if there's any difference. Okay, so it is interesting because here the TCP has more bandwidth and throughput compared with the UDP. And why is that? So I did some research. It is saying that the UDP flow, iPerf will do some internal bookkeeping. So basically, it is saying that UDP will check every datagrams, but TCP will only check once per stream. And also TCP is TCP is optimized for high-speed transfers, while UDP that is just optimized for low latency. Okay, so this is the first thing. And the second thing is to set the connection, set the network with 100 milliseconds of delay. For this, we have the UDP bandwidth, which is significantly greater than the first one, but has significant loss of datagrams. But for TCP, we have also significant drop of performance, and also significant drop of throughput. So why is that? If there's a change, why is that? So UDP bandwidth is not impacted by latency. That means whenever it is possible, it will occupy all the bandwidth. Okay. But TCP dropped significantly because TCP requires the receiving of the acknowledgement, and because of the network has delayed, so the acknowledgement takes a long time to go back to the sender. So the whole performance dropped. So for the third measurement, the delay is 0 milliseconds, but it has 10% of data loss. So the UDP is actually not infected by this kind of settings, but the TCP performance dropped significantly than the previous one. So why is that? So the UDP doesn't care about whether or not the data is lost. So yeah, the UDP doesn't change, but the TCP actually need acknowledgement to proceed, but because of the data has lost. This is much worse than compared with the latency issue. So the TCP, the timer of the TCP for that certain package will expire. Then the sender will send the package again. So that's the reason why the performance has dropped, because the sliding window, it has the possibility that the sliding window will move very slow. So the next measurement is to change the MTU. The default MTU is 9001, which is a very big one. So I changed this to a small one. So changing the MTU to small one will infect the UDP and also the TCP. So the next measurement is to set the TBF. What is TBF? TBF I listed here. TBF is the token bucket filter. It's set to 100 megabits. So this is like the maximum bandwidth that the sender could have. So after, and also we change this latency to 1 millisecond and burst for this for 9,015 bytes of data. So for this, UDP has a high bandwidth, but the TCP has very low bandwidth. Why is that? So this is because we have limited the maximum bandwidth of the package that we can send, but we will send much more than the bandwidth that it could bear. So this will cause the significant loss of data, and also for TCP, the significant drop of the performance of the throughput. So this command would like to change the speed of the network interface, but the AWS doesn't allow us to do that. It's probably because of the AWS has some hardware limitations that prevent us from changing the speed of the adapter for some security reasons. Because if we can change the speed, then we can change it to any speaker that we want. Also, because the Amazon Cloud, it is the virtualization, so the true NIC card might be very powerful. So if we change this to a very big number, it might congest. It might congest the connection. So for some security reason, Amazon doesn't allow us to do that. Next is to run this command to see if there's any error or logs in the kernel. So I got two logs. The first log is when I first run the tc command, which is to add something, to add the parameters to the network operating system. I received this this error, this log. The second thing is that when I change the MTU to a very large number, then when I set the burst number to the number that is lower than the MTU, I got this log. Okay. So then the next thing is to do the same thing on the VYOS on the interface that is not mapped to elastic IP. So this is just actually the same measurement, and I will not go through this because I have a summary in this slide. So will you be able to get the same observation as before? Actually, no. And so under the 100 milliseconds of latency, bandwidth and throughput of UDP and TCP, which is these two values, with limitations on client and server side are greater than the limitations on VYOS. So these two values are greater than these two values. So this is the first observation. The second observation is that in the second set of the parameters, the throughput of TCP, which is this value, is much less than the limitations on VYOS. So this value is much less than this value, but these two values are the same. On the third parameter set, it has, so the bandwidth of UDP dropped significantly, and also the TCP throughput somehow increased significantly. This is the third observation.